Hello, my name is Muhammad Iqbal Habibie and I am from Indonesia.
Hello, my name is Muhammad FAIQ and I'm from Indonesia.
Hi guys, my name is SHABRINA SAKRONI and I'm from Indonesia.
I'm class SHEBANI. I am 19 years old and I'm from Libya.
Hey everyone, my name is ABDULRAHMAN AHMED RAFAT. I am from Egypt and I...
Hello, I'm Henry MESHACK OKINYI ODONGO and I come from Kenya.
Hello and good day everyone. We are from Boink Group. This is our last project, our last report project for computer organization and architecture. We will present about copy a string backwards. That means we will write an assembled program that copies a string from source to target. So reversing that character order in the process. So like usually, first of all, we will share our code. From this code, this is our program. From here, we can see from line 4 until line 15, it will be the menu text in the output. We try to debugging and we see it's same. Please select from the menu, one copy a string backwards to return the current original string and 3 exit. We will try to do, we press 1, then it will say please enter a string, and for example I will write I am happy. Then and when we enter, the reverse string will be YPPAHMAI. So from here we go to the first step again and we go to 3 for exit. Our member will explain it step by step. So happy watching everyone. Have a good day.
Hello everyone, my name is Muhammad HAIDAR. Here I am going to explain the code from line 17 until line 30. So in the code main procedure, I think there are start with input, return value, find and, swap loop and done, which each of them have their respectively instructions. And the part I'm going to explain is start. So first move EDX offset menu text. We set the value of EDX with the offset of menu text, then call a string to show the string from the offset that EDX points to. After that, call for decimal prompts user to input a decimal value, and the input will be stored into EAX. CMP EAX1 means we compare EAX to 1. If EAX is equal to 1, then 0 flag is also 1, and we can jump to with input. Otherwise, if EAX is not equal to 1, 0 flag will be 0, and we continue the next CMP EX2. We compare EX to 2. If 0 flag is equal to 1, then we jump to return value. Otherwise, 0 flag will be 0, and we continue to the next. CMP EX3, we compare EX to 3. If 0 flag is equal to 1, then we jump to done. Otherwise, 0 flag will be 0, and we continue the next. GMP start means if the AX is not equal 1 or 2 or 3, which is invalid option, the program will back to start. Here, I will run the code. What? I am happy. It will be reversed from the original one, and then lastly exit. So the program will end. Maybe that's all on my part. Thank you very much.
Hello there, I'm Henry and we're going to look at lines 32 all the way through 41. So basically we'll be looking at the section of with input. So now I will just run the debugger. And basically we are presented with a prompt to enter from the menu. So at line 33, we're going to see what's being displayed in the memory 1, registers, autos, and watch 1 windows. So I'll just select option 1 and press enter. And as you can see, it's showing all the memories. Here it's showing the registers, and it seems like the register EAX has the value of 1. So it's an unsigned integer. This is what the unsigned means over here. And basically we also have the value of EDX given and what the input text is. So once I've selected that, I'll just step over. This is now looking at line 33. So we've stepped over and we're on line 33 now. So basically this is what's happening. The offset input text has been moved to EDX. and we're going to step over again. Now we should see the call write string. So call write string should be happening, and some values of the registers here have changed. I'll just step over again. So here we moved the offset source value to EDX, and as you can see, the value of EDX is changing again. Then now moving the value of 100 to ECX, we can clearly see that in the auto section of the code that the ECX has the value of 100, and we know that 100 itself is an unsigned integer. Let's step over again. So now I'm going to enter a string. So this is a continuation. I'll just type hello and press enter. Yeah, now since we stepped over, we're on line 39, and basically the offset source value has been moved to ESI. As you can see, the red indicates that the values have indeed changed. I'll step over again, and now we should see a change in the EDI register. And bam, there we have it. A change in the EDI register, also being equal to the ESI register. And I'll step over again, and we should see a decrease of EDI by 1. So there we have it. Before it was 4219159. Now it's 4219158. So yeah, that's all from what's happening here. And as you can see, I've been debugging, and I've basically run the program to see what is going on in these particular lines. So thank you for watching.
Hello, my name is ABDULLAH SHEBANI, and today I'll be explaining line 43 to line 48 in our COA project. Okay, so let's start. So in line 43 we have find end, and in find end we want to find the last offset in the string, or the inputs inputted by the user. So what we do here is in line 44 we increment EDI. Now EDI here points to an offset. So we increment, if you increment it by 1, it will point to the next offset. And then we move in line 45 we have moved the EDI. So what this does is that it removes the value of the offset EDI is pointing to, and it will move it to AL. In line 46 we have compare AL0. Then in line 47 we have jump find end. So what this does here is that if AL is not 0, then it will jump back to find end, so that EDI will be incremented again and will point to the next offset. Because if it's not 0, then the offsets EDI was pointing to was not the final offset. So we go back to find end again, and we increment EDI by 1 until we find the final offset. If it is 0, if AL does equal to 0, then we go to line 48 where we decrement EDI by 1, or decrease it by 1. What this does, we do this process basically to return the pointer to the inputted by the user, or the string that was inputted.
Okay, so next up we this line we will set the value of EX with the offset that EDI points to, and then we will need to subtract the value of register EAX with the offset that ESI points to. And after that we will set the value of register EVX with 2, and similarly with register EDX we will set its value to 0, which will be used later on to store the remainder for the division process. Okay, so next up we will divide the value of EVX with the remainder set to the value of EDX. And this division process must be done because the loop must end when ESI and EDI meet in the middle. Okay, so after that we will just move the value of EAX to register ECX, and then we will add the value of ECX to the value of EDX, and this process must be done because ECX will be used as a counter for the loop, and therefore remainders must be included to prevent loss when having a odd number of offset and inputs.
Alright, let's move on to the next bit of line here. So the next code. So first one, we have the label for swap loop, which will be used to swap the letters or the values. So for example, here I put I am happy. So it will be YPPAH space MA space I on the result later on. So here you can see the I am happy is actually within this right here, with the additional 0 of the source being this one, and then this one to the next case. So now we move the value which it holds into AL for ESI, which is here. So now ESI holds I, and then we move EDI, which is 79, into BL, Then we use the exchange instruction, which swaps the value of AL with BL, or exchange the value. So now AL and BL would be swapped. So AL would be lowercase y, or 0x79, and then BL would be 0x49, which holds the uppercase I, as you see. And then we move that back. After the swapping, we move that back into the memory. So we swap and put the 79 on where the ESI was, and then we set also the EDI value that it points to with BL, which holds uppercase I. There you go. As you can see, the result can also be seen here. The Y is up now to the front, and the I is at the back. And then we move the pointer. So we increase that. You can see at the bottom left at the watch 406118. So now it moves to here, the space here. And then we also move EDI back from here to 70, or P, lowercase p. That's pretty much how the concept works. So if we loop this, and then we're gonna move the value of space here into AL, and then we move the value of lowercase p into BL, just like before. We swap it and then move it back. So you can see here, the P is now here, and the empty space is now here. This will continue until the counter hits the 0. You can see the change at the right. You can also see at the bottom left. There you go. So this is the final one, where we swap H with the empty space. In here. There you go. So this is already at the correct position. And since the counter is only one left, we put loop here, it will become 0 and it will move on. It will show the text on the screen. You see here, the reverse string, and then it will show the actual source. So we just need to call source. And here, as you see, will show the reverse string from I am happy. So that's how it works. And then it will jump to start, which returns back to the top here and show the main menu again. So here, for example, I'll press this. There you go. It will appear again. And you can select another option. Here, if you put 2 in, here, the reverse string is I am happy again. So it returns back to the original. So here, return the current original string. So now it will return back again to start, and it'll show the menu again. If you press 3 here, as you can see, it will compare it, and then it will jump to done, which is going to be here, and it exits the application, or terminates the program. So that is all for the demonstration. Thank you very much for watching, and we'll move on to the reflections. Finally, after the demonstration is finished, it's time to move on to the reflections part. So this is the group project. It was worked by the whole group. Again, thankful for them for finishing their parts, for the code and also for the video. I'd like to especially thank one of the members, which is FAIQ. He's also the one who edits the video and pretty much leads the project here. I helped out in the coding process pretty much, and the others also helped on with the coding and the video. So from this project, we've learned pretty much, we used all the knowledges which was included in the labs and also the lectures before, such as instructions. You also have the registers manipulations, how to do the addition. We also learn more about the ESI and EDI, which is a pointer for source and destination. We also learn instructions such as exchange. We also have loops. We have jumps, conditional jumps, and no conditional jump or the normal jumps. Labels pretty much, and how to read from the memory, how to watch the variables such as the registers, or maybe the actual variable that you make from the data, and that's pretty much it. We also would like to thank Dr. Aida for all the lectures helped and given during this semester. For this project, we were able to understand fully all the knowledge that was used and was explained by her. That is pretty much it. We also would like to thank everyone who's watching the video, all other persons who are helping this video and also the project. We would like to thank you as well. That is all from us, and goodbye, and thank you.